but still we are far from the idea of the simulation, because as I said, the idea of the simulation itself is to be as close to the real world as possible, to be able to really understand that what the scene, the operation that we simulate, they are close and or almost identical to what we will see in the real world, on the real factory, in the real warehouse, or whenever we want to set up our robots. So for the physical simulation, again, the idea of the physical simulation is to simulate, taking into the account all possible physical characteristics. So we need to take into account, of course, rigid body dynamics. We need to find the collision. We need to, again, if there is a soft body model that we use in our simulation, then we need to implement soft body dynamics or fluid dynamics. This is everything that is actually used in the real simulation projects. We need to, during the physical simulation, we need to estimate, for example, in our case, how the mass, how the friction, how the inertia is affecting our movement. Yeah, so here I think is interesting video that will show us why is that important. So in the first case, we have just nothing. And for example, if our robot releases an object, it just stays and is floating in the space, which is really not what is happening in the real world. At the second option, we don't have collision detection. Okay, we have gravity, but no collision, and you can see we are still far from the realistic description. For number 3, we don't have rigid body dynamics. So for this form, we understand that in real world, it's not going to slide because the mass, center of the mass is moved. And only the number 4, where we apply all these characteristics, looks like something that we might see in the real world. Okay, let's move on. Okay, for the physical simulation, we will probably, again, if you have an appropriate education and a few years of the free time, maybe less, we can try to describe and develop everything by ourselves. But in most cases, we will use some already physical engines. And the most popular at the current time are these options. So it could be ODE, a physical engine that is widely used in games and in 3D gaming. Probably you know some of these games. Bullet is also a very popular physical engine, mostly used for different animation and 3D graphics in films and cinema. PhysX, that's more about simulation in CAD systems, in some university researchers or something like that. Vortex, that's also a very interesting one. It's not free, and again is used for the academic projects, used by militaries and in some other cases. Again, there are lots of options that you can find. It depends on your task, what exactly you want to simulate. Maybe you want something more lightweight and can find something that will fit and meet your requirements. Okay, again, currently we can describe the robot, we can visualize that, we can teach the robot, we can plan the path, the trajectory for the robot movement, and we can simulate the real world behavior for the robot simulation for the robots.